Hello friends and welcome to YouTube channel on Engineering Mathematics by Dr. Navneet. On today's lecture we are going to discuss evaluation of an integral using Laplace transformation. Friends, we know that, so how to find the integration of the type integration 0 to infinity, then e raised to, suppose this is minus 2t, then t raised to 6 dt. So we know the method of solving such type of integration. For solving this type of integration, so we are first applying the concept that is called as LIATE rule. So then according to the LIATE rule, this exponential function is the last function, so we can rewrite this as integration 0 to infinity and t raised to 6 e raised to minus 2t dt. Then for finding this integration, we are applying the concept that is called as integration by parts rule. According to that rule, we can write this as first function integration of second minus derivative of first integration of second, and so on. So that means after applying LIATE rule, we are applying integration by parts rule. Then after applying this rule, we are finding the derivative and integration of the given function. So after finding a derivative and integration of given function, so we are putting the value of upper limit and we are putting the value of lower limit, and after doing the simplification of some term, so we are reaching towards the final answer. So this is the method which we people know for finding the value of such type of integration. But in this lecture we are learning how to find the value of such type of integration with the help of Laplace transformation. Where we are not applying LIATE rule, we are not applying general rule for integration by parts, we are not doing any integration, we are not taking any derivative, and we are not getting the complicated thing which we are learning with the help of this concept. Now we are solving the integration of such type of thing with the help of Laplace transformation. So now first try to understand that for solving such type of integration with the Laplace transformation, so there are 4 different types. So first type is that we are solving the concept of integration of this type of with the help of definition. So we are solving this type of example with the help of definition, first part. Then second part is that, so we are solving such type of example with the help of first shifting theorem. So with the help of first shifting theorem, we are also solving example. Then third method for solving such type of integration is effect of multiplication by P property. And next concept is that, so we are applying effect of division by T property. That means for finding the integration of such type of equation, we are applying 4 different concepts. We are solving such type of example with the help of definition, with the help of first shifting theorem, with the help of effect of multiplication by T, and with the help of effect of division by T property. Now let's take the example which is based on the definition of the Laplace transformation. So we know the definition of Laplace transformation, so we can write this as for definition. So first topic is for definition. So we know that the definition of Laplace transformation, integration 0 to infinity, then e raised to minus st f of t dt is equal to, this is the value of Laplace transformation of f of t. So this is the definition. So now based on this definition, we will try to solve the example. So now let's take the first example, so that with the help of that example your idea will get clear. So now first example is, suppose we wish to find or evaluate suppose integration 0 to infinity, then e raised to minus 3t then t raised to 5 dt. So now we wish to solve this integration. So for the evaluation of this integral, so we are applying the concept that is called as Laplace transformation. So take the help of definition of Laplace transformation. We know the definition of Laplace transformation: e raised to minus st f of t dt is equal to Laplace transformation of f of t. That means we are taking the Laplace transformation of this function only. So if we compare this example with the help of this definition, then we can write this definition as integration 0 to infinity e raised to minus 3t then t raised to 5 dt is equal to, this is the value of, after comparing this example with this definition, this is the value of Laplace transformation of f of t. We can write this as Laplace transformation of t raised to 5. But for writing this as Laplace transformation of t raised to 5, we require this step as e raised to minus st. Now here we get the value of e raised to 3t. So replace this 3. So replace this 3 by s, and after getting the final answer, so put s is equal to 3 so that we get this required example or required equation. So that means as a time being, just adjust the term e raised to minus st. So finally put s is equal to 3 so that we will get the given example. So now according to the definition of Laplace transformation, this is e raised to minus st, e raised to minus st as it is. Then f of t, value of f of t is t raised to 5. So then according to this definition, we will write this as Laplace transformation of t raised to 5. Then we know that there are some standard results for finding the Laplace transformation, which we learned in our previous lecture. So Laplace transformation of t raised to n is of the form t raised to n is equal to n factorial upon s raised to n plus 1. So here the value of n is 5. Value of n is 5. So we can write this as 5 factorial upon s raised to 5 plus 1. We get the value of 6. So here we get the value of Laplace transformation as 5 factorial upon s raised to 6. But in this example, we find the value of this term and we require the value of this term. So now to get this required term, so if we put the value of s is equal to 3. So in this example, if we put the value of s is equal to 3, then we get this as integration 0 to infinity e raised to minus 3t then t raised to 5 dt is equal to 5 factorial upon, this is 3 raised to 6. Put s is equal to 3. So that means, so we get the original equation as it is after putting s is equal to 3. So this is the adjusted term so that we get the definition of Laplace transformation. So in this way we solve the example based on the integral using Laplace transformation. So only important thing about this method is that for solving the example based on this method, we require the limit as 0 to infinity, because in definition limit is 0 to infinity. Whenever limit is 0 to infinity, then and then this method is applicable. Otherwise this method is not applicable. So now because of this is happened because of the definition of the Laplace transformation. In the definition of Laplace transformation, limit of this integration is 0 to infinity. So whenever limit is 0 to infinity, so we can apply the concept that is called as evaluation of an integral using Laplace transformation. Now this is the first example which is based on the definition of Laplace transformation. Now let's take the next example. Now we will take one more example. So next example is find, evaluate integration. Suppose this is 0 to infinity, then we can write this as e raised to minus 2t into sine cube. Suppose we can write this as t sine cube of t into dt. So now take this as the simple example. Again, if we compare this given example with the definition of Laplace transformation, then we can write given example as integration 0 to infinity e raised to minus 2t into, this is sine cube of t dt is equal to. So according to this definition of Laplace transformation, we can write this as Laplace transformation of sine cube of t. But for writing this as sine Laplace transformation of sine cube of t, so we have to write first term as e raised to minus st. So now here we will adjust this term as e raised to minus st, so that finally if we put the value of s as 2, then we will get the required equation. So now at the time being we will adjust this term as e raised to minus st. Now find out the Laplace transformation of sine cube of t. So we know that, for finding the Laplace transformation of sine cube of t, so these standard results are not applicable. So first convert this sine cube of t into the one of these standard results, so that we can find the integration of this equation. So we know the formula. So this formula is sine cube of t is equal to 1 upon 4, then this is 3 times sine of t minus this is sine of 3t. So this formula we know from our first lecture of this Laplace transformation. So if we apply this formula, then we get this Laplace transformation as Laplace transformation of 1 upon 4 in bracket, this is 3 into sine of t minus sine of 3t. So this is because of the trigonometric formula. So now according to the linear function, so let's simplify this. This 1 upon 4 is common, then in bracket we get this as, so we will write here rectangular bracket because we are using rectangular bracket for Laplace transformation. Now let's use here as a curly bracket. So 1 upon 4 into 3 times Laplace transformation of sine of t, then minus Laplace transformation of sine of 3t. So now just solve this equation. So if we try to solve this equation, then we get this as 1 upon 4, then this 3 as it is, then Laplace transformation of sine of t. Laplace transformation of sine of at is a upon a square plus a square. If we compare this result number 4 with this example, then we get the value of a as 1. So after getting a is equal to 1, we write this as 1 upon, this is a square plus 1 square is 1 minus, again next term is Laplace transformation of sine of 3t. So same result is applicable, but here the value of a is 3. So we can write this as 3 upon, this is a square plus 3 square, which is 9. So now after simplifying this term, we get this as, after taking 3 common from numerator, so this is 3 by 4, then take the term a square plus 1 and a square plus 9 denominator common, so that we get this as a square plus 9 minus this is a square plus 1. So now if we simplify this once again, then we get this as 3 upon 4, then so denominator as it is, so denominator is a square plus 1, then a square plus 9, so this denominator is as it is. So then this is plus a square, this is minus a square will get cancelled, this is plus 9 minus 1, so in numerator we get the value of s as, we get the value of numerator as 8. So this is the final answer for the Laplace transformation of sine cube of t. So but here we adjust the term as e raised to minus st. We require here term as e raised to minus 2t. So now to get the required equation, so put the value of s is equal to infinity in this example. So if we put s is equal to infinity here, then this integration become integration 0 to infinity e raised to minus 2t, because s is equal to 2, then this is sine cube of t dt is equal to. So again, so put the s is equal to 2 on left hand side as well as on right hand side. So here the value of right hand side is, so this is 3 by 4, then 8 upon, so put s is equal to 2, so we get this as 2 square plus 1, and again this is 2 square plus 9. So simplify this, this is, so 4 ones are 4, 4 twos are 8, so 3 twos are, we can get this as 6, then this is 2 to the 4 plus 1 5 into 4, and this is 9, so we get this as 13. So final answer is 6 upon 13 5s are 65. So this is the final answer when we put s is equal to 2. So now these are the two examples which are based on the directly definition of the Laplace transformation. So now take some examples where we are using the first shifting theorem of the Laplace transformation. Now friends, take the example which is based on integration of the equation, and where we are using the definition of Laplace transformation and first shifting theorem. So now let me write the definition of Laplace transformation. Integration 0 to infinity e raised to minus st f of t dt is equal to Laplace transformation of f of t. This is the definition of Laplace transformation, and we are using the concept Laplace transformation of e raised to at into f of t is equal to, this is phi of s minus a. So this is called as first shifting theorem. So if here sign is plus, then we write this as phi of s minus a. So if sign is minus, then we can take the middle sign as minus. That means we are learning how to evaluate integral with the help of Laplace transformation. For this, we are using the definition of Laplace transformation and first shifting theorem. Now to understand this concept, take the first example. So example is evaluate. Suppose first concept is evaluate integration 0 to infinity e raised to minus t, then we write this as sin h of t into sin of 3t dt. Now to evaluate this integral, so first we are applying evaluation of integral by Laplace transformation concept, because here limit of this integration is 0 to infinity. So because of the limit 0 to infinity, we can easily apply the concept of definition. So if we compare this example with the help of definition, then we can write this as integration 0 to infinity e raised to minus t, then sin h of t into sin of 3t dt is equal to, this is Laplace transformation of sin h of t into sin of 3t. But so we can write this term as Laplace transformation of this function. Only this is possible when the first term is e raised to minus st. Here e raised to minus st is required. Now available term is e raised to minus t, so we can adjust this term as s, so that after putting s is equal to 1, we will get the original equation as it is. And because of this adjustable term s, we can write this as Laplace transformation of sin h of t into sin of 3t. Now next step is to find out the Laplace transformation of this function. Now to find out the Laplace transformation of this function is not in our standard form. Now first convert this equation in terms of standard form. So for converting this equation in terms of standard form, we know that sin h of t is equal to e raised to t minus e raised to minus t upon 2. So if we apply this concept, then we get first term as e raised to t and second term as sin of t 3t, so that we get the first shifting theorem, or we can apply the first shifting theorem. So if we apply this result here, then we get next step as e raised to t minus e raised to minus t upon 2. This is the first term into sin of 3t. So find out the Laplace transformation of this function. Now here observe that this 1 upon 2 is constant, take outside the Laplace transformation, and again according to the linear property we can write this as Laplace transformation of e raised to t into sin of 3t, middle sign is minus, and Laplace transformation of this is e raised to minus t into sin of 3t. So in this way we write this step. So now next step is to simplify this step, but here we observe that So this example, so this is the product of two term, and out of two term, first term is exponential. So now we can apply the first shifting theorem to this first term. So according to the first shifting theorem, so first find out the value of Laplace transformation of sine of 3t. We know that according to the formula, Laplace transformation of sine of 80, which is a upon s square plus a square, we get this as 3 upon s square plus 9. Then our first shifting theorem says that if plus sign is there, that means a is 1, so we get the value of a as 1. Then when plus power is there, then we can subtract a from s, where a is equal to 1. So from this step, we write the answer of this term as, so 3 upon, this is s minus 1 its square plus, we can write this as 9. So this is because of the first shifting theorem of the Laplace transformation. Middle sign is minus. Again, if we find the Laplace transformation of sine of 3t, so again same, 3 upon s square plus 9. But here observe that, so this is e raised to plus 80. Now here we get this value as e raised to minus 80. Whenever e raised to minus sign is there, then add a to the parameter s, where here a is again 1. That means add 1 to s, we get this as 3 upon, this is s plus 1 x square plus 9. Now just simplify this. This is 1 upon 2. Then after taking 3 common from numerator, we get this as 1 upon, this is s square minus 2s plus 1 and plus 9, that means this is plus 10, a minus b square formula. Then minus, this is 1 upon s square plus 2s plus 10. So this is the required solution for the term integration 0 to infinity e raised to minus st into sine h of t sine of 3t dt. So but here we use the term e raised to minus st. In given example, term is e raised to minus t. Now to get the required term, so put the value of s is equal to 1. So if we put s is equal to 1, then this integration is integration 0 to infinity e raised to minus t, then sine h of t sine of 3t dt is equal to, this is 3 by 2. So now replace s by 1, we get this as 1 upon 1 minus 2 plus 10, again 1 upon 1 plus 2 plus 10. So further simplify this, so this is 3 by 2, then we get this as 1 upon, so this is 9 minus 1 upon, this is 13. So once again simplify this term so that we get the final answer. So now in this example, we use definition and first shifting theorem for the evaluation of an integral by Laplace transformation. Now let's take the example which is based on definition of Laplace transformation and effect of multiplication by t property. Now friends, discuss the third type for evaluation of integral using Laplace transformation. So in third type we are using effect of multiplication by t property. So now for this we are using the definition of Laplace transformation and effect of multiplication by t property. This property is Laplace transformation of t raised to n f of t is equal to minus 1 raised to n into nth derivative with respect to x of Laplace transformation of f of t. So this is called as effect of multiplication by t property. So now we are solving the example based on integration of integration. So where we are using definition and effect of multiplication by t property. So now to understand this concept, now take the first example, evaluate. So first question is integration 0 to infinity, then this is e raised to minus 3t into t, then sine of t. So now this is the simple question into dt. Sometimes so such type of question may be there, or so they may ask the question that show that integration 0 to infinity e raised to minus 3t into t sine of t dt is equal to, this is 3 upon 50. So they may ask this way or this way in the examination. Now friends, observe that if we compare this example with the help of definition, so we are comparing this example with the definition, because here limit is 0 to infinity. Whenever limit is 0 to infinity, compare this example with the definition. So after comparing this example with the definition, we get here as integration 0 to infinity, then e raised to minus 3t into t sine of t dt is equal to, so according to this definition, we write this as Laplace transformation of t into sine of t. But we write this as Laplace transformation of t sine t when the first term is e raised to minus st. Now here we get this term as e raised to minus 3t. So if we replace these 3 by s, and finally if we put s is equal to 3, then we will get the required solution. As a time being, just adjust this as e raised to minus st. This is adjustable term for getting the solution. Now it is possible for me to write down the definition of Laplace transformation. But here, if we try to find out the Laplace transformation of this function, then it is not possible for us to apply the standard result, because this is the product of two terms. But out of these two terms, one term is in terms of t. So this is t to the power 1. That means this is of the type t raised to n into f of t form. That means we are able, or we are eligible to apply the concept of effect of multiplication by t property. So according to this property, so we write this as minus 1 raised to 1, because value of n is 1. So into derivative with respect to s, again value of n is 1, into Laplace transformation of sine of t. So this is because of the effect of multiplication by t property. So try to simplify this, we get this as minus d by ds of, so Laplace transformation of sine of t, according to this fourth result, we write this as a upon s square plus a square, where the value of a is 1, we write this as 1 upon s square plus 1. Now take the derivative of this function, we write this as 1 upon, this is s square plus 1, its square. That means for finding the derivative of this function with respect to x, we are applying the rule of u upon v, rule of derivative. So denominator square, then denominator s square plus 1, derivative of numerator is 0 minus numerator which is 1, then derivative of s square plus 1 is 2s. So if we further simplify this, then value of first term is 0, and this is minus minus become plus, so this is 2s upon s square plus 1 its square. So this is the final answer. So we can write this as integration 0 to infinity e raised to minus st into t sine of t dt is equal to, this is 2s upon s square plus 1 its square. So this is the required answer. But in this answer, we use the term e raised to minus st, whereas we require this term as e raised to minus 3t. But if we put s is equal to 3, then we will reach to the required answer. So now this is integration 0 to infinity e raised to minus 3t. So we get the first term into t sine of t dt is equal to. Now replace s by 3 on the right hand side also. So we get this as 2 into 3 divided by, this is 3 square plus 1 its square. So we can write this as 6 upon, so 3 square is 9 plus 1 10, its square, this is 100. So we can write this as 2 3s are 6 upon 2 50s are 100. So we get this as 3 upon 50. So now this is the example where we use definition and multiplication by t property. So this is the first simple example. Now take one more example for clearly understanding this concept. So now take the example. so which is somehow complicated or which is critical, so that your concept regarding this evaluation of an integral by Laplace transformation will get clear. Now second example is evaluate integration 0 to infinity then e raised to minus 2t, then this is t square into sine of 3t dt. So this is one of the example. Or someone may ask this question as, some people may ask this question as integration 0 to infinity e raised to minus 2t then t square, then this is sine of 3t dt is equal to 80 upon 2197. So someone may ask the question that show that this is equal to 18 upon 2197. Now to solve this example, so here limit for this integration is 0 to infinity. So because of the limit 0 to infinity, so compare this example with the help of definition. So if we compare the given example with the help of definition, then we can write this as e raised to minus 2t into this is t square then sine of 3t dt. So now observe that, so according to this definition we can write this as Laplace transformation of f of t. So we can write this as Laplace transformation of t square into sine of 3t, but this is possible only when the first term is e raised to minus st. Now here our term is e raised to minus 2t, so we can replace this 2 by s. So finally if we put s is equal to t, then we get the required quotient. So now this just adjust the term e raised to minus st. So now here we have to find out the Laplace transformation of t square into sine of 3t. But this equation is not in our standard form. But this is the product of two terms, and out of these two terms, one term is x1, one term is power of t. That means this is of the type t raised to n into f of t. That indicate that we have to use effect of multiplication by t property. So if we compare this with the effect of multiplication by t property, then here the value of f of t is sine of 3t. So if we find its Laplace transformation, then this Laplace transformation is 3 upon s square plus 9. This is the value of phi of s. Then according to this effect of multiplication by t property, so we write this as minus 1 raised to 2. Value of n is 2, so because n is 2, then we can write this as second derivative of this function with respect to s of Laplace transformation of sine of 3t. So which is equal to minus 1 raised to 2 is 1. So we get this as second order derivative with respect to s of Laplace transformation of 3t. So this function is 3 upon s square plus 9. So 3 upon s square plus 9. Now take the two derivative of this function. So if we take the first derivative of this function, then we get this as d by ds of, so again u upon v rule. So we write this as s square plus 9 its square, then denominator s square plus 9, derivative of numerator, derivative of 3 which is constant is 0, minus numerator into derivative of denominator, derivative of denominator is 2s. So if we further simplify this term, then we get this as d by ds of, this is minus 6s upon, this is s square plus 9 its square. So for our simplicity, we may write this as minus 6 constant, then d by ds of, so we write this as minus 6 d by ds of, this is s upon s square plus 9 its square. So now take one more derivative. So this minus 6 as it is. So again denominator square, denominator is s square plus 9 its square and again its square, so raised to 4. So then denominator, so value of denominator is s square plus 9 its square into derivative of numerator is 1 minus numerator s derivative of denominator is 2 times s square plus 9 into again derivative of s square plus 9 is 2s. So now just simplify this. So we get this as minus 6, then in denominator we get this as minus 6 into denominator is s square plus 9 raised to 4. So it is possible for that to cancel the term s square plus 9, one power will get cancelled. So here we get this as s raised to 3 power, then this is s square plus 9, first term s square plus 9, so this will get cancelled, and this is 2 to the 4, so this is minus 4 s square. So 2 to the 4 and s into s square. So now if we simplify further this, then we get this as minus 6 into this is 3s square minus sign s square into minus 4s square is minus 3s square, then plus 9 divided by s square plus 9 to power 3. So now this is the simplification. So moreover we can write this as, if we take 6 to the inner side minus 6, then minus 1 become plus 6 3s are 18 s square, then this is again minus 54 divided by s square plus 9 its cube. So this is the value of integration 0 to infinity e raised to minus st, then this is t square into sine of t dt. So but this is not the required question. So in required question power of e is minus 2. So if we put the value of s is equal to 2, then we get the next term as integration 0 to infinity e raised to minus 2t, then t square into sine of 3t dt is equal to. So put s is equal to 2, so we get this as 18 into 2 minus 54 divided by this is 2 square plus 9 its cube. So if we simplify this term, then we get answer as 80 upon 2197. So in this way we can solve the example which is based on the integral, and we are using the definition and effect of multiplication by t property. Now let's take the example which is based on the definition of Laplace transformation, and we are using the concept of effect of division by t property, but we are learning this concept in the next lecture. So let's take some example for your practice. Friends, now time is to test your knowledge. So now for your practice purpose, so based on the evaluation of integration by Laplace transformation, so let's solve these 4 examples. So these examples are based on the definition of Laplace transformation, then definition along with first shifting theorem, and definition along with effect of multiplication by t property. So this is the first example. So second, third and fourth examples are there. Along with these examples, answers are also given. Friends, I hope you like these lectures. So thanks one and all for patiently listening this video lecture. Thank you.